Next, we have differentiability of a function f(x) at any point, say x equal to a. So what does this mean? It's the same as asking, is f(x) differentiable at x equal to a? So this means that you need to determine whether f prime a exists or not. And in this case, we will also apply the concept that we learned in chapter 8 limits about one-sided limit. If you can show that the limit of fx minus fa divided by x minus a as x approaches a from the left-hand side is the same as the limit of fx minus fa divided by x minus a as x approaches a from the right-hand side is the same. So if both limits are the same and they give you a value of L, this means that you will have f prime a, which is equal to limit of fx minus fa divided by x minus a as x approaches a. So just like in chapter 8, if left-hand side is the same as right-hand side, you can make the conclusion. So just ignore plus minus sign because this means that the left-hand side is the same as the right-hand side limit. Except that for this one, instead of just fx, you're gonna apply the formula for first principle when x is equal to a. So, if you have this conclusion, what does it mean? It means fx is differentiable at x equal to a. So, let's try and do example 2, question 1. We are given this fx and we need to determine is fx differentiable at x equal to negative 1. So you need to check whether f prime negative 1 exists or not. Since x is equal to negative 1, this means that x equal to a is given. And hence, we'll be using this formula of f prime a. But first thing first, draw your number line for fx, which is this one. So, if you need to find whether f prime negative 1 exists or not, and you have this piecewise function, you need to determine the left-hand side and the right-hand side. So let's start with the left-hand side first. As x approaches negative 1 from the left-hand side, this is our fx. So copy down this formula and bring it to here. Note that a is negative 1, fx is 3x squared minus 1, and we also need fa. And we know that a is negative 1. So this means that you're going to substitute negative 1 into fx. So f negative 1 is 3 times negative 1 squared minus 1. So now we just need to simplify the numerator. Note that this is actually 0. And the denominator is actually x plus 1. So if you substitute x equal to negative 1 into x, this will give you 0 over 0, which is case 2. For this question, we're going to use factorization. We can just cancel out minus 0. Note that you can factorize x squared minus 1. And that will give you 3 times x plus 1 times x minus 1 divided by x plus 1. Cancel out x plus 1. And hence, by substituting x equal to negative 1 into x, you will get the answer is negative 6. So this is from the left-hand side. Now let's do the same thing for the right-hand side. As x approaches negative 1 from the right-hand side, this is fx. So as per usual, we'll be using this formula in here. Okay, I'm so sorry, but I forgot about the negative sign. Don't forget, since it is approaching from the left-hand side, all the limit here should have the negative sign. Now, for the right-hand side, it means it is a positive sign. So, change a to become negative 1. Next, we need fx. So, as x is approaching -1 from the right hand side, our fx is 1 over x. Next, we need fa. A is -1, so we need f -1. Since fx is 1 over x, therefore f -1 is 1 over -1. So now just simplify everything here. This is actually plus 1. And this is actually x plus 1. If you substitute x equal to -1 into x, that will give you 0 over 0, which is case 2. So we need to factorize for this question. So equate the denominator for this part, and it will give you 1 plus x over x. But don't forget about your denominator. And hence, you can actually cancel out x plus 1. So this is actually just 1 over x. And hence, by substituting x equal to -1, you'll get 1 over -1, which is -1. And hence, you only need to compare the left-hand side and the right-hand side, which is not the same. So now, let's make the conclusion. For the left-hand side, we have this formula, and we know that a is -1. And for the right-hand side, we have this formula, and a is -1. And they are not equal. If the left limit is not the same as the right limit, just copy the same as this one here, except that this time, it is just x approaches -1. There is no longer plus or minus here. So, does this limit exist? The answer is no, because they are not the same. So, this limit does not exist. And hence, if it does not exist, you can write down fx is not differentiable at x equal to a. But don't forget, in this case, a is -1. So that is how you determine whether a function is differentiable or not. So just as a reminder, this is actually f prime -1. So that's what we need to find. This is the same as saying f prime -1 does not exist. So this is the correct way of writing your conclusion based on your limits from the left-hand side and the right-hand side. Before we stop, let's look at this extra bit here. Say that you need to find whether f prime 2 exists for a certain function, and say that this is a piecewise function. So you need to find the left-hand side and the right-hand side. Okay, so for the left-hand side, say that you do the calculation and you get the answer is 3. And for the right-hand side, you do your calculation and you get your answer 3. If you compare both answers, you can see that they are the same. So make your conclusion that this limit is the same as this limit. Which is equal to 3. So, if the left-hand side is the same as the right-hand side limit, you can make the conclusion that this limit exists. But don't forget to put the value, which is 3. But this time, here, you no longer need to put positive or negative, because you have already proven that this limit is the same as this limit. So what is this limit actually? This is the same as f prime 2. So you'll get f prime 2 is equal to 3. And therefore, fx is differentiable at x equal to 2. And that is how you write the conclusion for a function when it is differentiable at x equal to 2.